This video is a tutorial slash explanation for the current world's smallest 4x4 hipster door, which you see here. This was done by myself with a little help from High 30, but previous versions of the door, which was the same layout and concept but slightly bigger, High 30 helped out more, as well as Res XD. Alright, let's get started. So this door is 4 wide, 10 deep, so 3 on one end, 6 on the other, and 6 tall, so 1, 2, 3, 4, 5, 6, below the floor. So we'll first start with the layout. First we have a piston stack 4 tall right beneath the door frame. We also have a piston fold, so 4 more pistons on the side. And we also push observers into the stack through here. Come on. For our inputs, we have a line of repeaters here. This powers the stack as well as these pistons here. Now, to prevent these pistons from pushing into the stack, well, there's already pistons here, we have immovable blocks. These are transparent for later. And on top of these, we have 4 4-tick repeaters, as well as observers facing up into blocks. And this forms a double piston extender. So that's 2 of our inputs. A third one is going to be powering these bottom pistons. And for that, we use a chain of observers here. This is going to be a note block, and then this is going to be a glass pane or a fence and a trapdoor. So now, powering this will power all 4 pistons. And our final input is going to be powering these observers, these pistons that push the observers in. And to do that, we can't place a dust here, and we can't place a repeater because that'll go outside the size of the door. So what we use is pressure plates and armor stands. So our pressure plates are going to go there on transparent blocks. Actually, let's place the armor stands first. So place 2 armor stands here, and we're going to push them against some walls. So now the armor stands are approximately in the middle of the block, and they're going to be pushed up by these pistons. Push 4 blocks into the top of the armor stands, like so. Transparent blocks. You can also use upside down slabs. And on top of them, we're going to place pressure plates. So now, when we power these pistons, the top pistons power, and they unpower. We will actually one-tick these pistons. So it essentially toggles these pistons being powered. So let's fill in the rest of these pistons. So that's all our inputs. We have 4 inputs: the double piston extender, the one-tick, and also the fold, the bottom, and the observers. And that is all the inputs we need to do the opening of the door. Now for the closing and the storage, we have the blocks are stored by being pushed here. And we're going to store 3 blocks, and we need 1 more so that the double piston extender can still power. And these are going to be pushed back by a piston worm. So let's do that. Actually, before I fill this in, let's place the observers to power the worm. So we have a bunch of upwards facing observers, and 1 more on top of the redstone dust line here. And beneath this, we're going to place a bunch of observers coming out of here. And now if I fix this and power. So now if we place the worm back here, which is normal pistons, sticky pistons, and solid blocks here. Also, we need to place in there a 2-tick repeater that will power our double piston extender and also these observers. So now if we power this 3 times, that does our closing. Okay, so that's the layout and the input. Now we're going to start on the wiring. So first, we're going to do the closing, and the way we do that is with a hopper ROM. So replace that with a dust. Actually, this is going to be on top of a note block for later. And then create a hopper ROM over here, and like so. And inside this, we're going to place 3 unstackable items and then 4 stackable items in between of 2 different kinds, and each of different kinds. And now if we power this, the signal strength is going to change 3 times, giving us 3 pulses. So this happens on both edges of the lever. So that does the closing and also the first move of our opening, which is just to pull the first block down. So that's our closing. Now the rest of the door, the rest of the space is going to be used for the opening. Now, the way we control the opening in such a small space is we use a shulker box ROM. So we have a double chest of shulker boxes, and we're going to dispense these one by one. And each of these shulker boxes has a signal strength when read from a comparator. And then we decode that signal strength to control one of our 4 inputs. And that does the whole opening sequence of the door. And that's how we were able to get this door so small. So let's get started on that. I want a normal chest without MBT. Okay. So first we have 2 double chests here, and a hopper there. So before the opening, all the shulker boxes are going to be in this chest. And then during the opening, they're going to be dispensed one by one and flown to this chest, but this hopper is locked. And during the closing, this hopper gets unlocked and all the items returned back to this chest. So our shulker boxes are going to come down through this hopper into this dispenser. And they're going to be broken by this piston. I'm going to break that comparator for now. And they're going to be collected by this hopper facing that way. We're also going to read the signal strength of those shulker boxes with this comparator. Now, because it's a comparator here instead of an air block in front of where the shulker box is being broken, there's a chance that the item might spawn like in the middle of the comparator and like fly out somewhere and not get picked up by the hopper. So to prevent that, we use a hopper cart clipped into the comparator. The hopper cart has a collection radius slightly larger than the block it's in, so it'll collect the item no matter where it goes. Also, we want to clip it into the comparator instead of letting it sit on top, because there's a chance the item might spawn below the hopper cart and not get picked up. So otherwise. So place rails, curve the rail into the comparator, and then just push a hopper cart into there. Let's give it a little more. And then push it back so there's room for the shulker box to dispense. Now, to control the items shulker boxes being dispensed one at a time, we have a redstone block there, which locks that hopper, and we momentarily remove that block with this piston. And then this redstone block moving also powers the dispenser. So now, if we give this a quick double pulse, which we can do with a 3-tick repeater and an observer, and we actually put some items in there. So put some shulker boxes. These give a signal strength of at least 4. Well, this gives the signal strength of exactly 4, but for testing, have any shulker boxes which give a signal strength of at least 4. So when we power this, the first time it just puts 1 item into the bottom hopper. Next time we get our shulker box dispensed, and we get an output from the comparator. Also, to complete the loop, we have 2 choppers facing up into these 2 hoppers. Now, to break the shulker box, by powering that piston, we simply observe here, which gets powered by that comparator, and that powers the piston. That note blocks there as an updater. So now if we power this again, get a box, and it gets picked up and put in there. And this gives a 2-tick pulse here. Now, a note normally with a 2-tick pulse, if you have an observer read a 2-tick pulse, it only gives 1 pulse, like so. However, here, even though this is still a 2-tick pulse, because of update order priority shenanigans, comparator piston something, I'm not sure. For some reason, this actually gives 2 pulses when read from an observer. So we use that in our decoder. Yeah. Okay. So now that we have this working, for now, we're just gonna spend small shulker blocks at a time. And this is unpowered, so the items just flow back into here. This hopper's unlocked, so items just flow back into here, which is fine for now. So now let's move on to the decoder. So our first input is going to be the delta piston extender, which we want to power when this gives a signal strength of 1, but not any higher. So the way we do that is we read the signal, and that powers this piston, and that goes into here. That needs to be turned sideways so it doesn't power that dust. So now let's bring this input over so we can see things easier. That powers a delta piston extender. However, when the signal strength reaches a level of 2 or more, we push this piston out of the way, so it no longer powers delta piston extender. So that's our first input. Our next input is going to be pushing these armor stands up. And the way we do that is and that's going to be with a signal strength of 2. And the way we do that is when the signal strength is 2, that powers this note block, which we then observe using these 3 observers. And that powers this sideways. So this is a monostable, and that powers this block, which powers these pistons. So now if we power this, oh, I didn't put the dust there. So if you power this, that one takes these pistons and toggles those observers. So that's the signal strength of 2. However, when the signal strength reaches 3, we don't want to power this, and our signal strength 3 is going to power this repeater line instead. So the way we do that is when the signal strength reaches a level of 3, it's going to power this observer. Also put a trap chest there to redirect the line so it doesn't power the stack. So when the signal strength is 3, we're going to just power this into another monostable that powers this hopper and into our 1-tick. Now, this, as it turns out, already disables this, our observer input, when the signal strength is 3. And the way that works is when the signal strength is 3, both of these pistons are going to power. However, this one fires 1 tick sooner than this one. And so this piston fires first, and that updates this observer. And so the observer is already being powered when it gets pushed over. And then when it gets here, it only gives like a 0-tick pulse, which is not enough to power these pistons. So if it's easier to see if I pull a line here. So if you see, yeah, that powers first, and so this gives a 0-tick pulse, which doesn't power these pistons. And then that 3-tick also powers our 1-tick repeater line here. Now our last input is the bottom pistons. Now the way we wire this is instead of having another like decoder, so like this only powers if the signal strength is 3 but not 4, we always power the one tick together with the bottom. So that way, so when we power the bottom, we power the one tick first, and after some delay, we power the bottom. That way, we don't have to do another decoder here. So all we need to do is just detect when the cyclic strength is 4 and power the bottom after some delay. This also powers the 3 tick, the 1 tick. So the way we do that is, in this trap chest, place 2 items. So that gives a signal strength of 2 from this comparator. So this comparator will turn off when the signal strength here is greater than 2. So when this signal strength is 3, or the comparator signal strength is 4. And then we observe that happening through here, this observer chain, and that powers this piston and that block. And this has to be some block which changes the instrument of the note block. So now if we power this, we see we get the 1 tick. We didn't get the 1 tick. Did we? We did get the 1 tick. So we get the 1 tick, and then the bottom piston's power. All right. That's all our... Okay, let's just clean this up. I'll fix it later. So that's all our inputs. So now let's get on to the clock for the opening ROM. So what we do is we just observe this note block being powered by the shulker box, and that goes into 3 tick here, a piston facing downwards, and there, back into that piston. Also turn this sideways to make sure it doesn't power that piston. So that's our clock. Another thing, however, right now, although these droppers are being powered by the comparator, the last item is going to be stuck in the bottom dropper and not sent back to the top chest. So the way we fix that is we just power these droppers again using this observer and this piston, and that needs to be in this state. So that will power the bottom dropper, then the top dropper, sending the last item all the way into the chest. And also every item in between, but whatever. Yeah, so that's our clock. And now to start the ROM, remember that we need 2 pulses to start the ROM. The first one is just to get the first item into this hopper, and then the second one, let me just disable the clock real quick. The second one actually gives our first item, which powers all the stuff. So turns out to start the ROM, all we need to do is just read from the closing ROM, which also powers this note block. That gives our 2 pulses. So during the closing, the items start in here. During the closing, the boxes start in here. And then, so during the closing, when the lever is unflicked, this unlocks the hopper and items start flowing to here. And then after a while, this powers once, and that sucks 1 item from the top chest, 1 item from this chest into that hopper. So like so. At least it's supposed to. Oh, I disabled this. Let's add that back. Okay, so during the closing, so this is after the opening, and during the closing, items go in here, and 1 item gets put in there. Now, because there's a bit of delay when before this powers during the closing, it actually sucks like the 3rd item out instead of like the 1st, which is not good, may not be good, because that changes the order of our sequence. The way we get around that is just our first 4 pulses are all the same, so it doesn't matter if they get rearranged a bit. We just power the observer 4 times. We have 2 redundant pulses. And that the first pulse is to push the first row of blocks into the storage. And we do that 4 times just so we can get around that problem. And During the opening, we just turn that lever, that locks this hopper, and then after a while, this turns off, and that gives our first pulse. And now it's clocking. And eventually, let's just help this out a bit. And all our items end up in here. Alright, so that theoretically should be the entire door. Well, we need to replace these repeaters first. Yeah, so now what you do is load up the ROM and give it a test. So I'm gonna reset everything first. So currently the lever is down, so it's in the open state. So let's reset it so it's like that. And then the last row is going to be right in the floor. And then I have the ROM saved in these double chests. These two chests. If you're programming this at home, this one has a signal strength of 1, the double piston extender. This one has a signal strength of 2, the observers. This one has a signal strength of 3, and this one has a signal strength of 4. You can pause the video and program that. And I don't recommend building in survival because then you got to do all this by hand, but oh well. So let's load up the ROM, control click the chests. Actually, in case I got something wrong, I already did that here. And then the right chest is, so you have the right chest and the left chest. Okay, let's start with that. Now let's clean up all the items in here. Make sure there's nothing in here. Nothing in this chest. Alright, and let's just make sure all these toggles are in the right state. Repeater's there. Okay. Looks good. So we have the closing. And then all the items are flowing. And then the first item's already there. And then we have the... Oh, just missing pistons. Okay. Let's stop that. Reset. Okay. So I've resetted it. It's supposed to be in the open state, but this is fine. We'll just do the closing and it'll get back into the right state. Now make sure, I did do this last time, make sure you wait for all these shulker boxes to flow into the other chest before starting the opening. Alright. Actually have all the pistons this time. Alright. Okay, let's test the opening. Oh, I disabled the clock. Let's just pretend that it happened by firing this twice. There we go. Now it's working. And looks to be working. Okay, I'm going to speed this up. Alright, and all the items are back in this chest, and we have the closing. Alright, that's the entire door. I'm gonna fill in the floor. Now a note, these blocks here above these observers can be either solid or transparent, it doesn't matter, and that's why it doesn't count towards the floor doesn't count towards the size of the door. So like the door will still work either way. So I'll just demonstrate that by having some of them solid and some of them transparent. Alright, let's get rid of all this. And now I'll just show the whole opening. So, and this is the end of the video. I'll just show the whole opening, and thanks for watching.